Let's take a look at some of our practice problems here from lecture number 14. And the first thing we want to do is just take a look at our Vesper structure practice. And we're just going to go through these and follow the 4 steps that we've got in lecture 14. So let's just do that. Step 1 is to draw a valid dot structure. And so first thing we need to do is find number of valence electrons. So our sulfur here is group 6. So it has 6 valence electrons. Fluorine is group 7, so it has 7 valence electrons, but there's 2 of them. And so we have a total of 20 valence electrons for SF2. So we'll take our first non-hydrogen atom, which is sulfur, and attach each of the fluorines to the sulfur with a single bond. And that used up 4 electrons. We'll keep our count over here. And we have 16 electrons left. Step 2 for doing our dot structure is to fill in the octets of the outer atoms first with lone pairs. So our fluorine needed 3 lone pairs. That used up 6. I have 10 electrons left. Let me fill up this fluorine with 3 pairs. That used another 6. I now have 4 electrons left. If we have any left after filling the outer electrons, we'll put them in as pairs on the central atom to fill its octet, or try to anyways. And we see here we did fill its octet. That used our last 4 electrons there. And so we now have a valid dot structure for SF2. As you can see, we have an octet for fluorine, an octet for sulfur, and an octet for the other fluorine. So in determining the structure, our second step is to count electron groups around each central atom. And here I have 4 electron groups. I have 2 bonding pairs, and I have 2 lone pairs around that sulfur. So I have 4 electron groups. So step 3 says find your electron group geometry. 4 electron groups will always arrange themselves as a tetrahedral, but that's the electron group geometry, not the molecular geometry. And step 4 is to find that final molecular geometry by ignoring those lone pairs. And we see here that I have 2 bonding pairs and 2 lone pairs. And when we look that up in our table, we would see that for 4 electron groups, 2 bonding pairs, 2 lone pairs, gives us a geometry of bent, and the angle between my fluorines is 105 degrees. So bent geometry at 105 degrees. Let's do the other one here. Our sulfate ion, So4 2-. And so we'll do our valence shell count again here. Sulfur again has 6. Oxygen has 6. And there's 4 of them. And we've got the 2- here. So that means I need to add 2 electrons. And so this is going to give me 32 valence electrons. So let's put our first non-hydrogen in the middle, sulfur, and attach everything to it with a single bond. That used up 8 electrons. I now have 24. So let's fill in the octets of the oxygen atoms. They're all the same. Each of them is going to need 6 electrons, or 3 pairs. And a quick mental math note there. 4 oxygens, 6 electrons each, will use up all of our 24 electrons. And they all go in as 3 pairs around each. That used up all 24, so I have no valence electrons left. And that's okay, because we see that each octet is filled around each of those atoms, so we're happy. And since all the octets are filled, we don't have to do any double bonds. So we have our valid dot structure. We have 4 electron groups around our central atom, and we see that they're all bonding groups. So 4 electron groups. Again, the electron group geometry is going to be tetrahedral, and since I have 4 bonding pairs, my molecular geometry is also going to be tetrahedral. And so I'm going to have 109.5 degrees bond angles for the sulfate ion. And now if we look at the clicker question, it says use Vesper theory to predict the molecular geometry of CO3 2-, the carbonate ion. We do much the same here. Let's just write down our formula, CO3 2-, figure out number of valence, get our valence structure here. I have 4 valence for carbon, 6 for oxygen. There's 3 of them. I have a 2- charge, so I need to add 2 electrons to that. This gives me 24 valence electrons that I can use to make the bonding. First non-hydrogen atom is my carbon. Attach everything to it with a single bond. That used 6. I have 18 left. 6 will get used here. 6 will get used here, and 6 will get used here. And that used up all 18 of my valence electrons that I had left. Now we see each oxygen has an octet, but the carbon does not, with only 3 bonds to it. So we're going to have to make a double bond, and we can take a pair from any of our oxygens and just move it there to make a carbon, so that one goes away. And now we have our valid dot structure for the carbonate ion. And so our next step is to count electron groups around each central atom. Here we have 1, 2, 3 electron groups. 3 electron groups arrange themselves in a trigonal planar arrangement. And you can see that in the table. And we see that we have 3 bonding pairs, and so the molecular geometry is also going to be trigonal planar, and my angle between all of my atoms is going to be 120 degrees. So if you see anything in there that's not making a whole lot of sense, go through it again. Make sure you read the chapter in the book. And if you're still needing help, make sure you come see me. Good luck.